So we are going to see another block diagram here, which explains our setup, some details about the multi-system setup we are having. Let's get into it. So we have the client computer here. So I'm going to use the terminology computer or system, server. I'm not going to use the terminology laptop or virtual machine or anything. So this is our client computer. Doesn't matter what system it is. And we have our Python application running in it. So this is our Python client application, and this is the user mode, and this is the kernel mode. And in the kernel mode, we have all our drivers, the AFD. We have seen this before, AFD. Then the almighty TCP/IP, TCP/IP.sys. Then the NDIS mini port, the actual device driver. Then finally, the device itself right here, the physical device which is present in the system. And it is physically connected to the iPhone. I'm going to call this iPhone as Wi-Fi router or simply router. So the correct term for that device is a router in this case. If you use anything like iPhone or hotspot or anything, it doesn't serve our purpose. It is a router from our discussion perspective. In fact, it is a router. Now, the other computer, which is the server. So this is our server. Again, server also has user mode, the Python application running along with other applications, the PY server. Again, it has user mode, kernel mode, and the AFD, just like the client because it's a Windows system. And then again, the TCP layer comes here, and it also has NDIS. Now, because of the bridge network, this particular virtual device, we can call it the device itself. It's a NIC, physical NIC created by VirtualBox, but we call it the NIC. This is also NIC, Wi-Fi NIC. This is not an actual Intel device. That's why I didn't name it Intel device. So this Intel D is Intel device. But essentially, it is exactly same thing. And it is also connected, physically connected to this particular iPhone. So this physical connection I'm talking right here, this physical connection is Wi-Fi. So it could be signals in the form of electromagnetic waves in this case. But it could be as good as an Ethernet cable. But for the sake of discussion, it is just a physical connection. So it's a two-way communication. That's why we have arrow mark back and forth. Now, from the diagram itself, one question comes into our mind. What is the need of this iPhone? Why can't we connect these two things directly? We will get to that later. That is one question we will address when we learn about IP addresses and routing in general. Basically, layer 3, the network layer. For the time being, just understand this particular device is needed. In fact, if you want, you can connect directly, but that's not the point, or that's not how things works in the real world. So this device right here, this router, has a paramount importance. It is not a trivial device. Now, let's see how our connect call works in this case. So the connect call is coming to the AFD. AFD is sending that connect to the TCP/IP. TCP/IP is generating the SYN packet. For NDIS, it is just like any other data. Whatever comes to NDIS, it's push it into the wire. That's the job of this guy. It has a device driver here of this particular guy right here. We have seen all these things. If you want, you can review those videos. But whatever comes to NDIS, whatever data comes to NDIS, it just pushes into the network, whatever connection mechanism it has. In this case, it's a Wi-Fi router, so it is going to be electromagnetic waves in particular frequency. It reaches here and it goes here, reaches this particular NIC, again it goes up. The SYN packet will come to the TCP/IP of the server. Now, will it do anything with the AFD? No, not yet. It will send the SYNAC. Again, SYNAC is coming back all the way through the network. It reaches this NDIS through the iPhone. Again, it comes here to the TCP/IP. Will it go up? Not yet. Now, the client has to send ACK for the SYNAC. So the three-way handshake has to be completed. So that is coming back just like before. Again, all the way through the router. It is coming to this NIC, goes up and reach here. That is when this thing will inform the AFD. The server is waiting on accept call. That is the assumption we have, while client is sending the SYN packet or the connect, and the accept call returns. Now, what if the server was not listening? If that is the case, instead of a SYN-ACK, it will send a reset. This packet right here would have been a reset from server. Server will say, hey, no one is listening on this port. I don't know what you're talking about. I'm resetting this connection. So there'll be a reset packet coming back. We have seen all this in the case of loopback connection. Exact same thing will happen in this case as well. We'll see all those permutation and combination. One thing is that it'll be a refresher for the previous sessions, as well as we'll see how it works in real world when we have two different IP addresses or two different systems. So this is the accept return. This is the connect call. Now, again, we are going to look at the layers of the network. So we have seen the different layers of network. So this is the application layer, this whole AFD. I'm going to include AFT in the application layer, although it is strictly not adding anything into the packet per se. AFD is a gray area, depends on whom you ask. It is the file interface for the socket. It's more of a operating system thingy rather than anything to do with the actual network. But I'm going to just put it as part of the application layer. Now, I'm not going to care about the presentation and session layer of the OSI. In fact, it is not present in most of the protocols, so we will be talking about application layer or layer 7. So we have seen our layer 7 is just the hello world and hello world from server. That is our layer 7 as of now. Now coming to the TCP layer or the transport layer. So this is the transport layer I'm drawing, half of the TCP IP, not fully because IP is also there. So transport, which is TCP in this case. TCP stands for Transmission Control Protocol. I don't think anyone uses that acronym these days. Everyone says TCP. If you're new to this, just say TCP and people will take you normal. But it is the transport layer. Now the IP layer, one of the most important layer, network or IP layer. Both the system has all the layers. Now the data link layer or the MAC layer, as you can see, the implementation of that layer is partially in the TCP IP and partially in NDIS, data link layer. Now the last layer is the physical layer, and it has the NDIS device driver, then the mini-port driver, the actual driver, the Intel driver for this device. That driver, everything including the device is part of the physical layer. Now, what about this iPhone sitting here? What layer is that? Apparently, iPhone is like a third system, just like the client and server. It is a device which is capable to have all the layers of the network, just like this. So the client has all the layers. The server has all the layers. It is a device which is accepting packets, so it can have all the layers. But mostly, it is operating only on the network layer and below. We'll see the details of that later, but for the time being, don't assume that it is just a physical layer the iPhone is about or the router is about. It is actually a layer 3 device. Don't worry much about the details of it, but just putting it out there. So this is the setup we are going to explore. It's the same application. We have moved to a different computer altogether, and we're going to look at different traces and traffic and look at different things. We're going to look at a little more detail on something called IP address, because the IP address didn't have any meaning until now because it was 127.0.0.1 until now. Now it has changed. You will see in your program the IP address has changed. So to conclude, we have seen the block diagram of this setup we are planning to explore. We are going to do similar kind of exploring we have done using TCP view and related tools like Netstat, Wireshark, and all the other tools we used to explore the loopback interface. Same thing we are going to do here as well.